Next one. If the first and the nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square equal to AB the whole raised to n. First term is given as A and nth term is given as B. Nth term means AN. AN is given as B. What's the formula of AN? AR raised to n minus 1 is given as B. So R raised to n minus 1 will be equal to B divided by A. And R is equal to B by A the whole raised to 1 by n minus 1. If R square equal to 3, we can write R as 3 raised to 1 by 2. If R cube equal to 3, we can write R as 3 raised to 1 by 3. Same way, since R raised to n minus 1 equal to B by A, the value of R will be B by A raised to 1 by n minus 1. Let it be here. What is P? P is the product of n terms. So I am going to take P. P is the product of n terms means first term is A, second term is AR, third term is AR square. And product of n terms means A into AR square into etc. Nth term will be A into R raised to n minus 1. So this is P and we have to show P square equal to AB raised to n. First of all, we will simplify P. So A into A which gives you A square into A which gives you A cube. So in each term, this is the first term, this is the second term, this is the third term and this is the nth term. So in each term there is an A. So A into A 2 times will give you A square. A into A 10 times will give you A raised to 10. Therefore, A into etc. n times gives you the value A raised to n. And what about R? R here it is R raised to 1. Here it is R square. If you are taking this term, it will be R cube. Then it will be R raised to 4 etc. So, since the base is the same R, we can add the power. So, 1 plus 2 plus 3 plus etc. plus n minus 1. So this is what we are getting as P. P need the value of 1 plus 2 plus etc. plus n minus 1. So let this be equation number 1. I am going to take the term 1, 2, 3, 4 etc. n minus 1. Actually this is an AEP, isn't it? Because 1 plus 1 gives you 2, 2 plus 1 gives you 3, 3 plus 1 gives you 4 etc. n minus 1. So it's an AEP with the first term 1 and a common difference 1 and a number of terms equal to n minus 1. So what we need in the power of R is 1 plus 2 plus 3 plus etc. n minus 1. That is sum is what we require. Sum is equal to 1 plus 2 plus 3 plus etc. n minus 1. What's the formula to find the sum? N by 2 into 2a plus n minus 1 into d. Here there are only n minus 1 terms. So n by 2 here it will be n minus 1 by 2 into 2a. 2 into a we got as 1 plus n minus 1. Here n itself is n minus 1. Okay. Minus 1 into d. d is 1. N by 2 into 2a plus n minus 1 into d. That's equal to n minus 1 by 2 into 2 into 1 gives you 2 plus this is n minus 2, isn't it? N minus 2. Minus 2 and plus 2 get cancelled giving you n minus 1 in by 2 into n. So we are getting the sum as n into n minus 1 by 2. Okay, this value we will substitute here as the power. So we are going to rewrite the equation. First equation once again. We got P as A raised to n into R raised to 1 plus 2 plus 3 plus etc. plus n minus 1. And 1 plus 2 plus 3 plus etc. n minus 1. We got the value now as n into n minus 1 by 2. So if I substitute what I get, A raised to n into R raised to n into n minus 1 by 2. And what is R? R is B by A raised to 1 by n minus 1. So if I substitute the value A raised to n into B by A. R is B by A raised to 1 by n minus 1. The whole raised to n into n minus 1 by 2. R is B, this much term raised to n into n minus 1 by 2 is here. So again B by A raised to a power raised to another power. So we can multiply the power. What we will get? A raised to n into B by A the whole raised to, if I multiply the power, 1 by n minus 1 into n minus 1 by 2. What I get is n minus 1 gets cancelled. So what we are getting is A raised to n into B by A the whole raised to n by 2. Let it be here. This is what is P. and what we have to show, p square is ab raised to n. So we will take p square is equal to this term square, isn't it? So a raised to n the whole square into b by a the whole raised to n by 2 the whole square. We have to square each of the terms. So a raised to n square into b by a raised to n by 2 is the term, its square is equal to, here also 2 powers are there, so we can multiply giving you a raised to 2n into, here also n by 2 into 2 is there. So b by a raised to n by 2 into 2, n by 2 into 2 gives you the value n. So what is the answer? A raised to 2n into b raised to n divided by a raised to n. This is b by a raised to n. So we can write as b raised to n by a raised to n. Here again look here, a raised to n and a raised to n have the same base. So we can subtract the power because it is divided by. So a raised to 2n minus n into b raised to n. 2n minus n gives you the value n. So a raised to n into b raised to n. If I am making these two terms together, instead of a raised to n into b raised to n, I can write the value ab the whole raised to n. Okay, so this was what? P square, and the question was to prove p square equal to ab the whole raised to n, and we got the value as p square as ab the whole raised to n. Just a simplification is there, and you must know the formula 1 plus 2 plus 3 plus etc. plus n minus 1 is n into n minus 1 by 2. Just directly apply the formula, and just a simplification, we are getting p square as ab the whole raised to n.